For more than a century, electricity has followed the same rule. It must travel through wires, from power plants to wall sockets, from devices to machines. Cables have always been the silent backbone of modern civilization. But today, that rule is beginning to change. In Finland, scientists are quietly working on technologies that could redefine how electricity moves through the world, not through copper or steel, but through air itself. Researchers from the University of Helsinki and the University of Oulu are pioneering experimental methods to transmit electricity wirelessly without physical cables. What once sounded like science fiction is now being tested in real laboratories. One of the most striking breakthroughs involves sound. Using high-intensity ultrasonic waves, frequencies far beyond human hearing, scientists have discovered a way to shape the air itself. These sound waves can create invisible, stable pathways in the atmosphere, guiding electrical sparks along a controlled route. This concept is known as an acoustic wire instead of a physical conductor. Carefully focused sound waves manipulate air density, forming a channel where electricity can safely and predictably travel. In laboratory demonstrations, electrical discharges follow these sonic paths, bending and moving through open space. For now, the technology remains expert. The distances are short and the power levels are limited, but the implications are enormous. In the future, acoustic wiring could enable contactless electrical connections, devices that power on without plugs, connectors, or exposed metal contacts. Smart interfaces could operate in sealed environments, immune to corrosion, moisture, or mechanical wear. But sound is only one part of Finland's wireless energy vision. Light is also playing a major role. In parallel, Finnish researchers and private companies are developing power by light systems that use high-powered laser beams to transmit electricity. In these systems, a laser carries energy across open space to a remote receiver, where it is converted back into electrical power. Unlike traditional wiring, laser-based power transfer offers complete galvanic isolation, meaning there is no direct electrical connection between source and receiver. This makes it especially valuable in hazardous environments, nuclear facilities, high-voltage substations, explosive or chemically sensitive locations. In such places, eliminating physical cables can significantly reduce risk. Today, these laser systems are already being tested for powering sensors, communication devices, and monitoring equipment in locations where wiring is impractical or dangerous. As efficiency improves, their applications may expand even further. And then there is radio. All around us, invisible radio frequency waves fill the air from Wi-Fi routers, cellular networks, and broadcast signals. Finnish innovation is finding ways to harvest these ambient waves and convert them into usable electrical energy. This approach has been described as Wi-Fi for power, while radio frequency harvesting won't run heavy machinery. It has enormous potential for low-power electronics, sensors, smart tags, and Internet of Things devices could operate indefinitely without batteries, drawing small amounts of energy directly from their environment. If scaled globally, this could eliminate millions of disposable batteries, reducing waste and maintenance while enabling vast sensor networks in cities, industry, and nature. Taken together, these technologies, acoustic wiring, laser-based power, and radio frequency harvesting, point toward a future where electricity becomes more flexible, adaptive, and wireless. Not all at once, not everywhere, but gradually, where wires are inefficient, dangerous, or limiting. Finland's role in this transition is significant. By combining academic research with private sector innovation, the country is positioning itself at the forefront of a new energy paradigm, one where power moves freely through space, guided by sound, light, and radio waves. We are still at the beginning. Challenges remain in efficiency, safety, scalability, and regulation. But history shows that every major technological shift starts this way, quietly, experimentally, almost unnoticed. Just as wireless communication once replaced wires for information, wireless energy may one day do the same for power. And when that happens, the infrastructure of the world may look very different. Electricity without wires,